there is a point charge of 20 microcoulomb whose refractive index is 1.5. Interesting optics में problem. 3.6 minus 1.2 into 10 power 6 is work function plus maximum kinetic energy. Hello students, this is SD Sir again from the Temple of Excellence, Vidhyaashram Pre-University, Mysuru. I have solved sufficient numericals from the chapters prescribed for second PUC physics course. From today, we will have the revision of the problems from the model question paper. Here, it is more me giving hints, concepts, and topics. I expect you all to substitute, simplify so that you become more authentic and more precise with the bookwork. The first question, the question reads that a point charge of 20 microcoulomb. There is a point charge of 20 microcoulomb situated at a point O. At some point O, we have placed a point charge of 20 microcoulomb. A and B are points 0.05 meter and 0.15 meter away from the charge. 2 points at two different distances. 1.05 meter and 0.15 meter. I have to calculate the amount of work done to move an electron from B to A. What amount of work has to be done to move an electron from B to A? As the first point of calculation, I will calculate the potential at those two different points due to the charge 20 microcoulomb. So we all know expression for potential V is 4 pi epsilon naught charge divided by distance. Derive ಮಾಡಿದೀವಲ್ವಾ expression for potential due to an isolated point charge. Here V1 is the potential, Q1 is the charge, D1 is the distance, which means V1 equals 9 into 10 power 9, which is the magnitude of 1 divided by 4 pi epsilon naught. What is the initial charge? 20 into 10 power minus 6. Initially, the distance is 0.05 meter. When I consider the point A, take your calculators. A very simple simplification where V1 turns out to be 3.6 into 10 power 6 volt. So this part of calculation is an assignment for y'all. Similarly, V2, again the same formula. Again the charge is 20 into 10 power minus 6, but the distance is now 0.15. And again on simplification, this is 1.2 into 10 power 6 volts. So I have calculated potential at the point A, which is V1, potential at the point 2, which is V2, and now I'll calculate potential difference between the points A and B. Potential difference between A and B. So this is V, which is VA minus VB, 3.6 minus 1.2 into 10 power 6, which is 2.4 into 10 power 6 volts. So once I have calculated the potential difference, how will I calculate the work? Again, very simple. V is again W by Q. In terms of work, I have defined potential. So W is V into Q. 2.4 into 10 power 6. What is Q? We are moving an electron. So charge of the electron minus 19. So on simplification, it is 3.8 into 10 power minus 13 joule. So very simple again. Problems are not hard miss to solve. Very simple. If you know the concepts, arriving at the results is very easy. The next one. A copper wire of 10 power minus 6 meter square area of cross section carries a current of 2 ampere. Cross sectional area is 10 power minus 6 meter square, and it is having or carrying a current of 2 amperes. If the number of electrons per cubic meter is 10 power 28, calculate the current density and average drift velocity. So I have to calculate current density and drift velocity. the first part of the calculation where I have to calculate the current density J. If you remember, what is the expression for J? It is nothing but I divided by A. So, I divided by A, I is 2 ampere, 10 power minus 6, or 2 into 10 power 6. What is the SI unit? Ampere meter minus 2. So, very easily I have calculated the current density. Next, what is that I have to calculate? Average drift velocity. So, I use the relationship between drift velocity and current, where we know I is N A V D into E. ಇಲ್ಲಿ VD ಕಂಡುಹಿಡಿಬೇಕು. Average drift velocity I divided by N A into E. If you observe, I by A I have calculated here only. Current density. Let me be smart enough in my work. So this is 2 into 10 power 6. How many electrons are there per cubic meter? N. So this is 8 into 10 power 28 into charge of the electron. So on simplification, again this turns out to be 15.6 into 10 power minus 5 meter per second. So very clearly, I need not break my head to solve such problems. Simple relations. Substitutions are very easy. Calculations you can see here. Next one. A 1 by 12 pi millifarad capacitor is connected in series with a 40 ohm resistance. Capacitance value ಎಷ್ಟು ಕೊಟ್ಟಿದ್ದಾರೆ? 1 divided by 12 pi millifarad. It is connected in series with 40 ohm resistance, and the supply value is 110 volt 60 hertz supply. I will first calculate the maximum current in the circuit. Very much while I have solved numericals on alternating current, I have worked such problems. So I'll ಹೇಳ್ಕೊಟ್ಟಿದ್ದೀನಿ. To calculate maximum current, what do I need to calculate first? Impedance. To calculate impedance, capacitor ಆಗಿರೋದ್ರಿಂದ first we will calculate capacitive reactance. So we know XC is 1 by 2 pi capacitive reactance. So this is 2 pi into 60. So this is 1 by 12 pi milli ಆಗಿರೋದ್ರಿಂದ 10 power minus 3 ಇರುತ್ತೆ. That pi gets cancelled 6 times, 10 times. Simplification is very simple. I want you all to do that. So this turns out to be 100 ohms. So if you calculate properly, here only you can see this pi gets cancelled. This goes 6 times. This goes 10 times. So 100 ohms is XC. Now we calculate impedance Z, which is root R square plus XC whole square. Resistance value is kottidare very clearly 40 ohms. So this is root 40 square plus 100 square. This is on simplification again 107 ohms. So Z impedance turns out to be 107 ohms. In order to calculate the maximum current, we will calculate the RMS value of current flowing through the circuit. So, third part, IRMS. How do I calculate? Ohm's law prakara I is V by R. Here V by Z impedance ಆಗಿರೋದ್ರಿಂದ. So this is V RMS by Z 110 by 107. So on calculation, this is nearly 1.2 amperes. IRMS ಕಂಡುಹಿಡಿದಿದ್ದೀನಿ. So can I calculate maximum current? Yes. I naught maximum current is IRMS into root 2 1.41. So which turns out to be 1.44 amperes. See, step by step, if I know the relations, I don't find any difficulty solving this. And finally, phase difference ಕೇಳಿದ್ದಾರೆ. So, phi is tan inverse of XC by R. Again, do the substitution. This is nearly 68 degrees. 5 relations, just 5 relations. I have calculated all parameters required. The next one, a small air bubble is found 0.04 meter inside a glass sphere whose refractive index is 1.5. Interesting optics male problem. When viewed normally from outside, it is seen at a depth of 0.03 meters. I am asked to calculate the radius of curvature of the glass sphere. A small air bubble is found 0.04 meter inside the glass sphere. So the object distance inside the glass sphere U is 0.04 meter. Refractive index of glass N1 is 1.5. When viewed normally from outside, It appears to be at a distance of 0.03 meter, V. I have to calculate the radius of curvature. Simple relation. No hacks and jacks here. No quantum physics here. Simple optics. Refraction through a spherical surface. N1 by U minus N2 by V equals N1 minus N2 by. This is all I require to solve the problem. N1, refractive index of glass. Object distance 0.04 minus refractive index of air 1.5 minus 1 by R. Now R has to be calculated. You have a simple calculators. Just simplify this. R turns out to be, that's all. See? No manipulations, no rearrangement of terms. Simple. The next one. This is an assignment for you all. I'll give you the topic. I'll give you the hint. You will solve. Calculate the change in stopping potential. Not the stopping potential. Change in stopping potential for photoelectrons emitted from a surface if the wavelength of incident light is reduced from 5,900 to 5,000 angstrom. And if you observe, the problem is in terms of wavelength. Change in stopping potential has to be calculated. I refer back to Einstein's photoelectric equation, where basically energy of the photon is work function plus maximum kinetic energy. Now, I want, or the question is in terms of wavelength. So, energy of the photon is hc by lambda. I keep the work function as it is because it gets cancelled. Stopping potential is required. Is it? Change in stopping potential. This is lambda 1. So, hc by lambda 2, W plus EV2. When you subtract this, the change in stopping potential will be equal to 3.78 volts. Just substitute for lambda 1 and lambda 2, subtract, substitute for H and C, you arrive at the answer. So in this session, I have worked out numericals from the model question paper. In my next session, I come up with one more model question paper. Until then, have a nice time. Thank you.